Hi everybody, in this video we're going to go over how to do some conservation of momentum problems. This is an Edpuzzle solve along video, so you should be following along with me as we're going through this together. Alright, let's get started. So the first thing we need to remember is the equation for momentum, and remember momentum is abbreviated with the letter P, is mass times velocity. And our mass is always going to be in units of kilograms, and our velocity is always going to be in units of meters per second. And that means our unit for momentum is called the kilogram meter per second. A little clunky, but that's what it is. All right, let's try and do this problem. So we have an 85 kilogram defensive tackle runs down the football field at 7 meters per second when he collides with a 70 kilogram tight end who is standing still to receive the football. The defensive tackle grabs the tight end and they collide. Okay, so they grab. How fast and what direction are the two football players moving after they collide? Okay, so with momentum problems, I think it's really important to start with a sketch. And I want to make a sketch for before and after the collision. Okay, so this is before, this is after. I'm going to draw a little line. Okay, so before we have two football players. I'm going to call the defensive tackle A and the tight end B. Okay, so let's say he's A, he's B. Okay, and before the tackle is running and the other guy, B, is staying still. Okay, so I'm going to draw that arrow to represent moving. And then after they collide, so they're like right next to each other. Okay, and they're going to be moving in some direction, but we're not sure which direction yet. Okay, so before we have A and B separate, and since they collide, I'm going to call this A plus B because they're kind of like one system together now because they have stuck together, they've collided. Okay, so I have my sketch before and after. And sometimes when it's solving momentum problems, okay, the next step is going to be to make a bar chart. So let's say I have, this is my bar chart, is going to be before and after. Okay, so we're going to have A, B, and then after is A plus B. Okay, so originally A is going to have some momentum because it has velocity, but B is not. And then after A plus B together is going to have some amount of momentum. Okay, so this is our bar chart. So we need to find the momentum of A plus the momentum of B, and that should be equal to the momentum of A plus B. Okay, so this is what we're going to use to guide us here. I'm just going to move this over. Oops, made it a little too big. Just going to take this and move it over here. Make it a little smaller so we can get it. All right, perfect. Okay, so sometimes it's helpful to make a little chart here where we have our mass, our velocity, and our momentum for before and after. Okay, so the mass of A we know is 85 kilograms. Mass of B is 70. And our velocity of A is 7 meters per second, right, from here. It says the 70 kilogram tight end is standing still, so that means its velocity is 0. And then after, their masses are going to combine. So our mass is going to be 85 plus 70, and our velocity we don't know, so I'm going to leave it as V. So now we can actually start calculating this momentum. Okay, so remember it's mass times velocity, so I'm going to say this is 85 times 7 plus 70 times 0. And it has to be the same before and after, so I'm going to put an equal sign, and then 85 plus 70 times V. And our goal here is to solve for V. That's our final velocity. Okay, so let's do some of this math here. So 85 times 7, I put that in my calculator, I get 595. 70 times 0 is 0. 85 plus 70 is 155. Okay, so now I can get rid of that 0. I have 595 equals 155 V. And I want to solve for V. So I'm going to divide both sides by 155. Okay, and I do 595 divided by 155 in my calculator, and I get 3.8 meters per second. And this is my final answer. One thing I forgot to note here was what my system is. So my system is everything we're calculating momentum for. So it's the two football players. Okay. All right. Awesome. So this is how we solve our problem. First, we did a sketch for before and after. Then we made our momentum bar chart and came up with this equation that we need the momentum of A plus the momentum of B, and that's going to be equal to the momentum of A plus B. Then we found the masses and velocities of everything we had. We used that to write the momentum equation, and then we solve for a missing variable. Let's try number 2. We have a 0.2 kilogram plastic ball moves with a velocity of 0.3 meters per second. It collides with a second plastic ball of a mass of 0.1 kilograms, moving along the same line at a speed of 0.1 meters per second. After the collision, both balls continue moving in the same original direction. The final speed of the 0.1 kilogram ball is 0.26 meters per second. What is the final velocity of the 0.2 kilogram ball? Okay, so we're going to do a very similar procedure here. We're going to draw our before and our after sketch. Take a second to try and do a sketch before and after the collision in your own notebook. Let's check it out together. All right, so we have two balls. Let's call the plastic one, let's call the first one A and the second one B again. Okay, so we're going to have A, and it's moving in one direction, and we have B, and it's moving in the same direction. Draw those arrows to represent that they're moving. And then after they collide, and they're still moving in the same direction, but their velocities are probably going to be different. So notice that in this one, it doesn't say anything about sticking together or holding on or grabbing on or anything. So that means these balls are still separate, okay? Which means they're gonna have separate velocities. So we have A, B, and then A, B, not A, B, and then A plus B. The A plus B, like we did in number 1, is because this said it grabs them, so they stick together. That's for if something sticks together. Here, there's nothing sticking together. There's no grabbing on or anything like that. And so we're going to keep them separate. So let's make our momentum bar chart. I'm going to make it over here so we have some more room. And here is our before. Here is our after. Okay. And why don't you take a second to try and draw this on your own? Let's look at it together. So before we have A and B, and then after it's A and B. And they're going to have momentums before, and they're going to have momentums after. But we don't know how much they are, but we do know they're all going to be positive because they continue to move in the same direction, right? It says continue to move in that same direction. So if we make that direction positive, then all of our momentums are going to be positive because all the velocities will be positive. So I'm just drawing 2 bars before and 2 bars after. And I can use this to have an equation, momentum A plus momentum B equals momentum A plus momentum B. So this is the kind of equation we're going to want to have. So let's try and make that same chart that we did before of the masses and the velocity and the momentum of each, before and after. So the mass of A is 0.2 kilograms. Mass of B is 0.1. The velocity of A is 0.3. The velocity of B is 0.1. Okay. Then after, the masses stay the same, right? So it's still 0.2 for A and 0.1 for B, right? And we don't know the velocity of A, right? We don't know the velocity of the 0.2 kilogram ball, but we do know the velocity of B, which is 0.26, okay? I want want you to take a second to write an equation now. Let's do it together. All right, so our momentums here, we're gonna multiply the mass times the velocity. So I have 0.2 times 0.3 plus 0.1 times 0.1 equals, okay, this got shifted a little bit, the equal sign should be for the after, 0.2 times v plus 0.1 times 0.26. All right, we want to solve for v. I want you to try this on your own. What is v going to be? Please put your answer in now. Now let's take a look at how we got that. All right, so 0.2 times 0.3. If we put that on our calculator, we get 0.06 plus 0.1 times 0.1, if you put in a calculator, 0.01 is 0.2v plus 0.1 times 0.26 gives us 0.026. I'm going to add this together, and I get 0.07 equals 0.2v plus 0.026. Now I'm going to subtract 0.026 from both sides. And I'm going to get 0.044 equals 0.2v. And to get v by itself, I'm dividing both sides by 0.2. And I put in my calculator 0.044 divided by 0.2, and I get a velocity of 0.22 meters per second. Very good. Again, here we did not yet put our system down. So our system should be everything we're finding the momentum for. So what is the system here? Our system is going to be the two balls, A and B, okay? So again, we did the same process here. We sketched before and after. We made our momentum bar chart with our equation. Then we figured out the masses and velocities before and after, put it into our momentum equations, and solve for a missing variable. Okay, we're going to do one more problem, very similar together. All right, we have a 0.4 kilogram wad of unexploded fireworks moves horizontally to the right at a speed of 2 meters per second squared. It creates a small explosion, which breaks the wad into two pieces. Okay, it breaks into two pieces. The first piece moves with a mass of 0.4 kilograms to the right at 40 meters per second. What's the velocity of the remaining piece? Let's start with a sketch. Okay, so before we have fireworks, they're moving to the right. And then after, it splits into two pieces. Okay, and then one we know is moving to the right, which means the other one's probably moving to the left. So in this case, this is sort of like the opposite of our first problem. In the first problem, we had two objects that stick together. And in this one, we have one object that splits apart. So let's call the pieces of the firework A and B. So let's say this is A and this is B. Then before we have A plus B. Okay, we have one big thing that splits into two, sort of like the opposite of two objects that collide and stick together. Okay, so these are the three different situations we could really have. We can have one thing splitting apart, we can have two things sticking together, or we can have two things that collide and bounce off of each other and are still separate before and after. Okay, but our system here is going to be the whole firework, A plus B. Okay. All right, take a second to make a momentum bar chart. So we have before and we have after. So before we have A plus B together, and then after we have A and B separately. And we know B is moving in the positive direction, which means A is probably moving in the negative direction, because if things are splitting apart, they usually move in opposite directions. So we're going to need to find the momentum of A plus B, and that's going to be equal to the momentum of A plus the momentum of B. Okay. So now let's make that same chart as before. We have the masses, we have the velocities, and the momentum. Okay. What is the mass of A and B together? It's going to be 0.4. Okay. And we know the original velocity is 2 meters per second. Then the mass of B, which is the one moving to the right, so this is 40 meters per second, and it's a 0.04 kilograms. And we don't know the velocity of A, but we can figure out the mass of A. Go ahead, what do you think is the mass of A? Well, let's take a look at this together. If its total is 0.4 and B splits off of it 0.04, A is going to be 0.4 minus 0.04, which gives us a mass of, let's put this in a calculator, 0.36. Okay, so this is our mass of A is 0.36. Okay, now go ahead and make an equation for this now. Let's do one together. So we have 0.4 times 2 equals 0.36 times V plus 0.04 times 40. We're trying to solve for V. Take a second to solve for V now. Let's take a look at it together. So putting in my calculator, I have 0.4 times 2 is 0.8 equals 0.36 V plus 0.04 times 40 gives me 1.6. So now I want to subtract 1.6 from both sides. And I'm going to get negative 0.8 equals 0.36 V. Then we're dividing by 0.36 on both sides. And if I put in my calculator 0.8 divided by 0.36, I get a velocity of negative 2.2 meters per second. Okay, and this is my final answer. Now, why does it make sense that A has a negative velocity? It makes sense because we know it's moving in the negative direction. If we assigned this as positive and this as negative, which we did because we said B had a positive velocity, that means A must be moving in the opposite direction, so it must have a negative velocity. So it checks out that we got a negative velocity. Awesome job. So in all of these situations, we started by drawing a sketch of the situation before and after. Notice that there are 3 different types of situations we might have. We can have one object that collides into another and they bounce, so they're separate before and they're separate after. We can have 2 objects that collide and stick together, so they're separate before but combined together. Or we can have one object that splits in half, so they're combined before and then separate after. And that's something we want to notice in our sketch. Then we use that sketch to make a momentum bar chart. Again, keeping into account whether these things are stuck together or apart. Then we use that to make an equation, and then we figured out the masses and velocities of each piece to make that into a momentum equation. So we have the total momentum before has to be equal to the sum or total momentum after. We put in our numbers, and then we always solve for a missing variable using our algebra skills. It's also important to note that your system should be everything you're calculating the momentum of. Hopefully that was really helpful for you. If you have any questions, feel free to message me in the chat or through Remind, and I will be happy to help.